Hello everyone, how are you all? Welcome to Deeksha Karnataka YouTube channel. And if you are preparing for your KCET, then definitely you are wondering how I can improve my scores in KCET, how I can score less than 10,000, how I can score less than 5,000. And our dream is to get you a rank below 1,000, and we will be successful in this if you follow our channel. So today I have brought a very important chapter, moving charges and magnetism, for you all. So if you can listen to me and hear my voice, please let me know. Also, we are going to discuss top 20 PYQs from this chapter. This is one of the chapters that I have already covered in the past Sankalp series. So theoretical doubts that you might have definitely will be covered in that portion. And if you still have any more doubt regarding theoretical portion or anything else, please mention that in the comment section, live chat section. And if you have not yet subscribed to our channel, then don't forget to subscribe to our channel and join the WhatsApp group. Also share it with your friends so that more and more friends can join up and listen to the live. Okay. Sriram is saying, sir, unable to solve physics question, please help. Worry not, you follow our channel, you follow us, especially all the physics lectures. Definitely your solving skills will improve. I will not only discuss the method to answer the questions, also the skills required to answer some questions. So everything will be discussed. You need to have some theoretical knowledge, but even if you don't have that knowledge, worry not, Sriram. I will help you in that matter as well, right? And yes, so if you after watching this video, if you still have any doubts, you definitely do mention that in the comment below. So we will start with our first question, and we will start from KCET 2025. Some of you are asking, sir, you are not doing KCET 2025 for the last chapter. I felt that the questions are slightly easier that year, so now we have brought some KCET 2025 questions as well. So let's see the question, and then we will see the option, and then we will try to figure out what could be the correct answer for this question. Two long thin parallel wires separated by a distance small r from each other in vacuum carry a current of I ampere in opposite direction. Then they will. So what will be the answer? So this is just a formula, and this formula you derive for your PU board exam. So this is just they ask you the formula, and because the current is being passed in opposite direction, so one current will be in this direction, another current will be in this direction. So what will be the nature of force between them, whether it will be attractive, whether it will be repulsive or not. So two opposite currents always repel each other. Remember that parallel currents attract each other, anti-parallel currents repel each other. So here they are anti-parallel because they are carrying current in the opposite direction. Each of them are carrying current I. So what is the force between them? Force, normal formula, force per unit length is given by mu naught by 2 pi I1 I2 by R. Okay, so mu naught by 2 pi I naught by I2 by R, and there is no square over here, only simple R is there, and that will be mu naught by 2 pi I square by R, and this force is repulsive in nature. So force is repulsive, so repel each other with a force per unit length of mu naught I square by 2 pi R. So R is correct, not the R square. So this is a simple, you have done the derivation, so nothing to worry up. So this derivation you have already done, I1 I2 by D. In this case, instead of D, they have given you R, so you put R. Okay, so don't get confused. This is an easy problem, and this came in last year. So KCET problems are not very difficult. If you just put little bit effort, you should be able to answer such question. Now let's move on to the next question. And if you Sriram, if you are listening to me, try to answer it along with me. a solenoid is 1 meter long and 4 centimeter in diameter. Okay, so it has 5 layers. It has 5 layers of windings of 1000 turns each and carries a current of 7 ampere. The magnetic field at the center of the solenoid. So this is again a simple formula based problem. Okay, we have, so you can see that from this chapter the questions are coming simple formula based. So we know that if there is a solenoid, and those formulas are very simple, not difficult to memorize or remember as well. So here we have a current carrying solenoid, and we know that the magnetic field inside a current carrying solenoid is given by mu naught Ni. Okay, so this is the formula that we are going to use. Mu naught's value we know, 4 pi into 10 to the power of minus 7. Current is given over here, 7 ampere. Okay, only thing that you have to find is n is not directly given. What they have given is that length is given 1 meter, 4 centimeter in diameter. Now diameter has nothing to no role to play over here. Okay, length is required because this small n is actually total number of turns. Small n is actually total number of turns divided by its length. That is number of turns per unit length. So that's why this length is important, but here length is also given as 1 meter, so you don't need to worry about it as well. Now let's read the question clearly. It has 5 layers of windings. So one layer has 1000 number of turns. So 5 layer means one after another. So one layer, then another layer, then another layer. So imagine that you are adding sellotape over a cylinders. Okay, one layer of sellotape contains 1000 turns, another layer of sellotape contains another 1000 turns. So total 5 layers are there. So total number of turns over here is 5000. Okay, 5 layers, each layer 1000 turns, so total number of turns is 5000. The length is given 1 meter, so length you have to divide by 1 meter, so it is basically 5000 is the number of turns per unit length. So number of turns per unit length we got. Mu naught value is known, 4 pi into 10 to the power of minus 7. N value is 5000 and current is given 7 ampere. Now because the current is given in as 7 ampere, what we will be using, we will, and mathematically you are not allowed to use any calculators in the exam, so you have to use your brain, your head to calculate some values. So here what we will be using, we will be using 22 by 7 as the value of pi, not 3.14, even though 3.14 is more accurate than this value, but this is also very close, so we will use this value into 5000 into 7. Now the problem is very simple. Now simplify this and calculate the value. So 4 5s are 20. So 20 into 2 is 44, and we have 440, and 1 2 3 zeros. So what I have done, 4 5s are 20, 20 into 22 is 440. Okay, simple as that. 20 into 22 is 440, and then whatever zeros are left we have just put it over here. So this is how you should train your mind. 4 into 5 is a number which gives you a multiplier of 10. That's why we multiplied these two numbers first, because if you do 4 into 22 you might be confused. You can do 22 into 5 also is perfectly fine. 110 into 4 is 440. So whatever way you do, but first you have to multiply with this 5 so that you get a multiplier of 10. That is very simple to manage. Okay, so now we have to see how many zeros are there. 1 2 3 4 zeros are there. So this is effectively 44 into 10 to the power of minus 3, or from the option you can see that it is only given up to 2 decimal, so 4.4 into 10 to the power of minus 2. So we have taken one more negative 10 power into the equation itself, so it becomes 4.4. So if you see all the options, definitely this is the correct answer. Now you might say, sir, we have done everything correctly, so why our answer is not exactly matching with this answer. The reason is that for pi we have assumed 22/7, not exact value of pi. Pi is an irrational number. Irrational number means it cannot be expressed in the form of p/q, that is in terms of fraction. But here we have taken a fractional value for pi, so our result is very, very close, which we are happy with. We do not have any complaints because we can find the answer. We can easily identify this is the correct answer, and excuse me, and we will get full marks for it. So easy formula, easy question, and a simple formula based problem only. Right? If you have any doubt, any question, please mention in the comment section. Also, I request you, if you can solve the question, please try to solve and mention the answer in the chat below. Okay, chat is very, very important. Keep talking. Two similar galvanometers are converted into an ammeter and a milliammeter. The shunt resistance of ammeter as compared to the shunt resistance of milliammeter will be. So we have a galvanometer. Okay, we have a galvanometer. Now the same galvanometer is first time it is converted into a ammeter. Okay, so it is ammeter, and next the same galvanometer is converted into a milliammeter. Okay, now they are saying which one will have, suppose the shunt resistance here is R1, shunt resistance here is R2, and they are saying which galvanometer should have a higher resistance. Okay, now remember that whenever a galvanometer is given, the maximum current through the galvanometer is given as well, and that is fixed. The maximum current through the galvanometer is fixed. Then how a galvanometer can measure current or voltage? Okay, that happens when through the current that is being passed in the circuit itself. So for ammeter, the current that is being passed through the circuit. So this current we are trying to measure, not the Ig. Ig has a fixed value. For a given galvanometer, Ig is fixed. The current that we are measuring, that determines whether it's an ammeter or a milliammeter. Okay, so that means if it is an ammeter, then the current which is flowing in the circuit, okay, portion of it we are taking and we are measuring it. So that is basically the current. That value we are trying to find. So this is ammeter. This is suppose I am writing capital I for ampere and small I for milliampere for this problem only. Okay. Now Ig is fixed. So what will be the current through the resistance R1 in this case? The current through resistance will be I minus Ig, and current through this will be small I minus Ig. Okay, this concept remains same for no matter what ammeter you are using. Sriram is saying, can you give formula sheet? I will give you formula sheet during the exam. Don't worry right now. Right now you focus on understanding the concept, solving more problems, and when you require to solve questions in quick time before exam, that time I will definitely give you a formula sheet. Worry not, formula sheet I will provide all the chapters combined. There will be only one formula sheet that you can keep with you before your exam. Okay. In the month of February, March, I will try to give you. Right now, don't use formula sheet. Right now, focus on understanding the concept and solving it. Okay, then only you will be able to memorize the formulas. If I give you formula sheet, you will not understand the concept. You will just memorize the formula sheet completely, and you will forget. Okay. And what will happen also, you will not be able to answer questions which are based on fundamental concepts. So formula sheet is okay, formula sheet is good, but the formula sheet, if you have prepared the chapter completely, then only formula sheet will help. Okay, so if you have completed the entire chapter, then formula sheet is very, very good. Otherwise formula sheet may not help you. Okay, so now let's see what is the current Ig that is being passed through the galvanometer and I minus Ig that is being passed through R1. Now in this case, the voltage across the galvanometer is constant, so we can write that Ig into G equals to I minus Ig into R1. Okay, so what is the value of R1? R1 is equals to G into Ig divided by I minus Ig. Okay, what will be the value of R2? Value of R2 will be same Gig by small I minus Ig. Now if you see that Ig's values are same, Gig, that is numerator, is also same, but for milliammeter the current for ammeter the current that we are using is very high compared to milliampere. Okay, this is milliampere, this is in amperes, so this current is higher, that means the division part is higher as well. Okay, so if you take any arbitrary value, say Gig value is say 10, okay, this is say 10 ampere as well, and Ig say 0.1 ampere, 0.1 ampere. Okay, so what will be the value? You will see it is almost equals to 1 ohm. Now let's put the same values for a milliampere as well, milliammeter as well. Gig is again 10. Now this value is say 100 milliampere, and this one is obviously 1 milliampere. 0.1 ampere means sorry, let's see, let's use 0.01 Ig. Okay, that is actually times 1000, that will be 10 milliampere. So you see that this is 10 by 90, so almost 1/9 ohm. So the resistance of milliampere is much smaller compared to resistance of ammeter. Okay, higher the current, the resistance required will be higher. Remember that higher the current that you are measuring, the shunt resistance required will be higher. So the shunt resistance of the ammeter compared to the shunt resistance of milliammeter will be more. Okay, will be more. Okay, so remember this fact that higher the current that you are measuring, that means this resistance is getting higher as well. If you are measuring a smaller current for the same configuration, the resistance that you require is lower. Okay, now next, before I continue, please I request you to join our WhatsApp channel if you have not yet joined. There all the important updates, all the whenever a lecture is going live, when I am coming live or other teachers are coming live, if the video is published or not, so every information will be shared through exclusively our WhatsApp channel. So don't forget to join our WhatsApp channel. Also subscribe to our YouTube channel if you have not yet subscribed. So the chat here is only for subscribers, so if you are a subscriber, definitely you can come and chat in the live chat section as well. So worry not, please, we are all doing hard work for you only, and you will be benefited more if you join our WhatsApp channel. All the PDFs, all the important notes, formula sheets, etc. will be exclusively shared through our WhatsApp channel only. So don't forget to join our WhatsApp channel and also subscribe to our YouTube channel to get all the important updates and information for your KCET preparation. Now, let's continue with again we are still in KCET 2025. So as you can see, in KCET 2025, this is the fourth question from KCET 2025, and the questions are not that difficult. All the questions we have solved so far. Identify the correct statement. So again, this is a statement based question. 4 statements are given, that means one of them is correct, remaining 3 are false, because they are asking correct statement. So again, this kind of questions can be tricky, as I mentioned. Identify the false statement, identify the incorrect statement, identify the correct statement, identify the true statement. Based on whatever is mentioned, the answer can change. So a straight current carrying conductor has circular magnetic field lines around it. A straight current carrying conductor does have a circular current carrying magnetic field around it. Circular magnetic field lines are circular. Okay, so this is a correct statement, but we will not stop over here. We will read the other statements as well. The direction of magnetic field due to a current element is given by Fleming's left hand rule. It is not correct. Due to a current element is given by the direction of magnetic field due to a current element is given by right hand thumb rule. The magnetic field inside a solenoid is non-uniform. This is again not correct. Magnetic field inside a solenoid is uniform. A current carrying conductor produces an electric field around it. A current carrying conductor produces only magnetic field, no electric field. Electric field is 0 around a current carrying conductor. So correct statement is option A. Okay. Now next question. This is again from 2025, so you can see that 5 questions came from this chapter. So this is a very important chapter. Do not ignore this chapter. If you study this chapter 4 to 5, average 4 questions every year will come from this chapter. 2025, 5 questions came from this chapter. So maybe that trend will be repeated for next year as well. Okay. Which of the following graphs represents the variation of magnetic field B with perpendicular distance small r from an infinitely long straight conductor carrying current? So what is the expression for magnetic field due to a straight current carrying wire, infinitely long current carrying wire? The magnetic field is given by mu naught by 2 pi I upon r. Okay, so this is the expression for magnetic field due to a straight current carrying conductor. Okay, so what does that mean? That means that magnetic field is inversely proportional with the distance. So if you increase the distance, magnetic field decreases, and that decreases depending upon 1 upon r. So 1 upon r, so what is the graph for 1 upon r? Now you see that this is not 1 upon r, this is not 1 upon r, this is also not 1 upon r, only 1 upon r is this. Now if you forget this, you have to remember this is same pattern as the electric potential. So you have learned electric potential and electric field. The graphs are almost similar. So this is a 1 upon r variation graph. So correct answer is option 1 in this particular question. Okay. Yes, Nagaraj. Hi Nagaraj, how are you? Yes, your answer was correct for 4A. Now answer question number 5 is already I have solved. Try to answer question number 6. Moving electron. Now we have moved into 2024 category. A moving electron produces only electric field, both electric and magnetic field, only magnetic field, neither electric nor magnetic field. So let's see this question, and I will give you some time. This is an easy question. I will give you some time to figure it out and answer it. Okay. If you are interested, please answer this question in the chat. In the meantime, I will have some water. Nagaraja is saying option B, and Malappa answer is saying both electric and magnetic field. Let's see. Moving electron produces only electric field, both electric and magnetic field, only magnetic field, neither electric nor magnetic field. So moving electron will produce both electric and magnetic field. Okay, electron, whether it is static or moving, it will always produce electric field. Okay, if it is a charge, static charge, that means it will always produce a electric field. Electric field is by its nature. Now when it is moving, okay, as soon as it starts moving, it also produces magnetic field. Okay, so only a moving electron, in fact moving electron can produce magnetic field, and later on you will learn that an accelerating electron produces electromagnetic waves. Only simple if the electron is moving with a constant velocity, the magnetic field will be constant. So in that case it will not be able to produce a electromagnetic wave, but if it is accelerating, then it will produce electromagnetic wave. But normally uniformly moving electron will produce both electric and magnetic field. Now let's move on. A coil having, again 2024 question, a coil having 9 turns carrying a current produces magnetic field B1 at the center. Now the coil is rewounded into 3 turns carrying the same current. then the magnetic field at the center B2 is equals to, what is the relation of B2 with B1? That's what we have to find. So first they have said that we have a coil, small coil, having 9 number of turns. Suppose the radius in this case is given by small r. Now when you take the same wire and rewound it, rewounding means the same wire, okay, you are making only 3 loops now. So 3 loops means what happens here, your radius will increase. Your radius will definitely increase. Okay, so when the coil was smaller, more number of turns was possible. Now the coil is larger, so less number of turns will be possible. So that's why the radius will change. Okay, everything else given in this case same current. Okay, so current is same. Now a magnetic field, what is the formula for magnetic field on the center of a current carrying coil? It is given by mu naught by 2 I upon R. Okay, so magnetic field at the center is given by mu naught by 2 I upon R. Okay, so now, so we can see that magnetic field is proportional to 1 upon R. Okay, so we can say that B1 by B2 must be equals to small r due to B1 and capital R due to B2, because it's 1 upon R, so that's why it is inversely proportional. Now we have to find the relationship between small r and capital R. That is our only target. So when you are rewounding it, that means total length in both cases must be same. Okay, total length in both cases must be same. So what is the total length in the case number 1? Total length, how to calculate total length? So it is a circular shape, so total length means we have to cut it and we have to measure it. That means the perimeter. So perimeter is given by 2 pi small r and total number of turns. So initially it has 9 number of turns, so 2 pi r into 9 is total length initially, and that should be equals to 2 pi capital R times 3. Okay, 2 pi r into 3 should be the final length. Both lengths should be same because it is coming from the same wire. Okay, so 2 pi cancels and we get 9 small r equals to 3 capital R, or capital R equals to 3 small r. Okay, so this is the relationship between capital R and small r. We will use that over here. So capital R is actually 3 small r divided by small r, so this is actually 3. So B2 is equals to B1 by 3. Just cross multiply it, B1, it will come over here, it will go there. So B2 equals to B1 by 3. So correct answer is option D. Okay. Nagaraj is saying option B. Nagaraj, I guess your answer is wrong in this case. So as you can see, it is inversely proportional to radius, and radius, because first case it is 9 turns, second case it is 3 turns. You have to calculate the relationship between the radius and then use this logic to answer it. Even if you don't know exact formula, even if you forget the exact formula, you have to remember that for center the magnetic field is inversely proportional to radius. Okay, magnetic field is inversely proportional to radius, and if you know that, you can easily solve this question. Now let's move on. Now some of the questions from this chapter was in 2024, I think one question was there which was out of syllabus, so I have not included that, but this question is slightly tricky. Let's see the question. A particle of specific charge Q by m equals to pi coulomb per kg is projected from origin towards positive x-axis with the velocity of 10 meter per second in a uniform magnetic field B equals to minus 2 k cap Tesla. The velocity v of the particle after time t equals to 1 by 12 second will be. So let us understand this problem. So here we are going to draw x-axis and z-axis, not the y-axis. Y-axis is there, x cross y is z, so y-axis is there somewhere here. but we are interested only in z-axis. Why? Because the magnetic field is given along the negative z-axis. So magnetic field is along the negative z-axis. Okay, why negative? Because it is minus, and why z-axis? Because it is given as k cap. So k represents z and minus represents negative z-axis. So magnetic field is along this direction, and the particle is projected along the x-axis. So the particle is moving in this direction. So this is the direction of velocity initially, and as we know that because magnetic field and velocity are perpendicular, it will tend to move in a circular motion. And what happens in circular motion? The magnitude of velocity remains same. So velocity does not change. Only thing that happens is that it will, if you want to calculate the velocity at this point, okay, you have to find the coordinate of velocity. If you can do that, you will be able to calculate what is the velocity. But first you have to calculate the time period. Okay, time period of the motion. So what is the formula for time period? Formula for time period is given by 2 pi into m by q b. Okay, so this is the formula for time period. Whenever a particle is moving in a circular motion in magnetic field, we know that 2 pi by omega, omega value is given by qb by m. So time period is given by 2 pi into m by qb. So we have to put the values over here now. So 2 pi. Now m by q is given here, q by m is given. Q by m is equals to pi. That means m by q must be equals to 1 by pi. Okay, m by q must be 1 by pi. So m by q is 1 by pi. And what is the magnetic field? Magnetic field is given by minus 2k Tesla. For calculating time period, we will not use the negative sign. We will only use the value, which is 2. So pi cancels. Pi cancels, 2 cancels, and we get 1 second. So 1 second is the time period. Now they said that the velocity of the particle after t equals to 1 by 12 second. So t, we know that if t equals to 1 second, what is the meaning of this? This is the time period. That means within this time it will rotate completely once. The particle will rotate completely once in this time 1 second. Okay, so how much it will rotate in 1 by 12 seconds? So how much it will rotate in 1 by 12 seconds? That is the question. So what is the meaning of one complete rotation? One complete rotation means it is actually rotating by an angle pi plus pi, that is 2 pi. So total angle in the time t is 2 pi. What is the time in small t? That will be 2 pi into 1 by 12. Okay, that is pi by 6. Pi by 6 is the angle of rotation. So we calculated the angle by which it will rotate, pi by 6. Okay, now we will apply simple vector formula to calculate the velocity. How to apply the vector formula? Now remember, as I mentioned, the magnitude of velocity will be same. Only thing that will change is its direction. So the velocity is given by Sir Isala NEET physics stuff Agi Barbuda. So Ramanan Gaura, we are not discussing NEET questions. Yes, this is a kind of NEET level question. I agree with this, but in KCET from time to time there is a tendency of 1 or 2 questions which is difficult. Maybe this year in 2024, even 2024 was a controversial year. Some questions was out of syllabus, some questions were deleted later on, but overall the rank hampered because of that. So you have to set your mind. If the question is difficult, remember yourself, if the question is difficult, it is difficult for all the students. Okay, not only you, everyone will face the difficulty. Okay, so Asian warrior is saying no. I don't know why you are saying no. So you have to understand that if the question is difficult, it will be difficult for everyone. Okay. Now let's see. What is the velocity over here? Velocity, as I mentioned, the magnitude of velocity is same, 10. Okay, magnitude wise it is not changing, only direction is changing. So the velocity vector will be 10 and the x component will be cos theta. So cos theta I cap plus sin theta j cap. Okay, so what is the cos theta? Cos theta is the theta value is this. This is the angle theta. Okay, so you have to first calculate the time period. From there you calculate the angle, and then from using the angle you use this simple formula, vector formula. Yes, it's a mixed concept question, not a single chapter question, but this type of question came from time to time. Okay, so cos pi by 6. Pi by 6 means 30 degrees. Okay, if you are confusing what is the value of pi by 6, pi by 6 means 30 degrees. So cos 30 is given by root 3 by 2 I cap, and sin 30 is half. So you can take half as common. Okay, you can take half common, so this will cancel the 10 and it will make it 5. Okay, so that will be 5 root 3 I cap plus j cap. Okay, so 5 root 3 I cap plus j cap. So correct answer is option D. Okay, correct answer in this case will be option D. Now let's move on to the next question. This is an easy question. Previous one was slightly difficult. Again we are into class year 2024. The magnetic field at the center of a circular coil of radius capital R carrying current I is 64 times the magnetic field at a distance x on its axis from the center of the coil, then the value of x is. So again this is the question based on the magnetic field on the center of a coil. So in this year 2 questions came from the formula based on magnetic field on the center of a coil. Okay, now let's see. So magnetic field, what is the way to calculate the magnetic field on the center of the coil? Suppose we have a magnetic field. What is the magnetic field at the center? So magnetic field at the center of the coil is given by mu naught by 2 I upon R. So this is easy. Magnetic field at the center is easy. What about magnetic field at a distance x from the center? So magnetic field at a distance x from the center is given by mu naught by 2 I into R divided by R square plus x square to the power 3 by 2. Okay, there is a square over here, right? Yes. Okay, now it is mentioned that magnetic field carrying current is 64 times the magnetic field at a distance x. So B center is equals to 64 times Bx. Okay, so now we have to calculate what is this value. Okay, now just put the values. Mu naught by 2 I upon R equals to 64 mu naught upon 2 I R square divided by R square plus x square to the power 3 by 2. So again mu naught by 2 gets cancelled, I gets cancelled, do the cross multiplication, you get R square plus x square to the power 3 by 2 equals to 64 R cube, or you can write this as 4 R whole cube. Okay, you can write 4r whole cube. So now you just need to cube root both sides. So if you do the cube root both sides, you get r square plus x square to the power half. Because we have taken cube root, so these 3 will no longer be there, and we get 4r. Okay, now cube root is gone, but there is still a square root is still there. So half means square root, so we have to square both sides. So if you square both sides, you will get r square plus x square equals to 16r square. Okay, so if you square both sides, you will get r square plus x square equals to 16r square, or x square equals to 15r square, or x equals to square root of 15r. Okay, so correct answer is square root of 15r. So correct answer here again option D. Okay, Nagaraja is saying yes sir, it's correct. Okay, thank you. So this is how you can solve this question. Okay, if you have any doubts, please mention in the chat so that I can read and reply to your doubts. Okay, now question number 10, the torque acting on, now we have moved into year 2023. The torque acting on a magnetic dipole placed in uniform magnetic field is 0 when the angle between the dipole axis and the magnetic field is dash. So torque acting on a magnetic dipole placed in a uniform magnetic field is 0. What is the formula for torque? Is an easy question. Torque is given by mb sin theta. Now in case you forget what is torque, you should remember the torque in electric field. It is given by Pe sin theta. Okay, this is in electric field. In case of magnetic field, this will be replaced by m and this will be replaced by b. So that's it. Now just name changes. Okay, so when you visit, if suppose you are visiting your maternal house, then their people call you by some name. Okay, when you come back to your paternal house, people call you by some other name. Okay, everyone has a nickname. Okay, your friends call you by some other name. Similarly, when electric field torque moves into magnetic field, only the name changes, but remaining things remains the same thing. Okay, so when the torque is 0, when sin theta is 0, when sin theta is 0, at the angle 0 degree. So again option D, 0 degree is the correct answer. Yes, 9D. Asian is correct. Nagaraja is also correct. Now easy question, easy answer. Now again, a proton and an alpha particle moving with the same velocity enters a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular path. So here basically a proton and an alpha particle both are moving in circular motion. Suppose this is the radius of proton, this is radius of alpha particle, then what will be the ratio of their radiuses? That is the question. Okay, now what is the formula for radius? Formula for radius is given by mv by qb. Okay, this is the simple formula, the simplest formula of all. So radius is given by mv by qb. Now what is the mass of a proton? Mass of a proton is simple mp. And what is the charge of a proton? Charge of a proton is E. Okay, now in case of alpha particle, what is the mass? Alpha particle has 2 protons and 2 neutrons, that means 4. Okay, protons and neutrons are almost of same mass, so we can say that mass of an alpha particle is 4 mp, whereas alpha particle is doubly positive, that means it has +2 charge, so that means its charge is given by 2e. Okay, so now we will use this to calculate the radius of proton, which is given by mp v by e into b. V and b are same, and our alpha is given by m 4 mp v divided by 2e into b. So one of them will cancel and we get 2 into mp v divided by E into B. So this is actually equals to 2 of radius of proton. Okay, so as you can see, the radius of so now the ratio of their radius. So be careful, ratio means you have to consider the order. So ratio based questions can again be tricky. So what is given first? First is given proton, next is given alpha particle. So what you have to calculate? You have to calculate Rp divided by R alpha, which is actually given by Rp divided by 2Rp, because R alpha is 2Rp. So Rp cancels, you get 1 by 2. So the ratio of the radiuses is Rp is to R alpha equals to 1 is to 2. So 1 is to 2 is the answer, not 2 is to the 1. So after solving, suppose you are solving this way, you might think 2 is to 1 can be the answer. So make sure you have understood, you have followed the order of the question, then only answer it. Okay, ratio based question can also get tricky. Even if you are solving them correctly, your final answer matters. Okay, that's why I say ratio based question and true false type question, when correct answer, correct statement, wrong statement, be careful in those type of questions. Okay, now let's see if you have answered this question or not. Yes, 11C, Asian Warrior and Nagraj both have answered it correctly. Okay, and Nagraj answered the previous question as option D as well. Now let's move on. Question number 12. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm, okay, and the shunt resistance has a value of 10 ohm. If there are 50 divisions in the galvanometer turned ammeter on either sides of 0, its current sensitivity is. So here we have a galvanometer. The question answer is easy, but they try to confuse you by giving some extra data which may not be required. So here they have mentioned this is a galvanometer. Okay, this is the galvanometer that you use in your laboratory, right? So there is a needle over here. Normally the galvanometer is like this. Okay, so it gives you 50 divisions on this side and 50 division on that side. Now what is the total number of divisions? Okay, so total number of effective division in this case is not 50 plus 50 100, but only 50. Okay, why? Because this represents 0. On the right hand side represents positive current, left hand side it represents negative current. So no matter whatever is the side given as like this, if it is fixed in the middle, only 1/2 you will be taking as the range of the galvanometer. That is very, very essential, and rest of the problem is very simple and easy. Okay, so ammeter into an ammeter of 0 to 5 milliampere. Okay, so a moving coil galvanometer is to be converted into an ammeter of range 0 to 5 milliampere. The galvanometer resistance is 90 ohm and the shunt resistance is 10 ohm. So now we will go back into the configuration of the galvanometer, which is galvanometer and a shunt resistance. Okay, now so the current that is being passed through the galvanometer, the maximum current which can pass through the galvanometer is given by 5 milliampere. Okay, but this is not the galvanometer current. Be careful, this is not the galvanometer current. This is the range of the galvanometer. That means this is the maximum current the galvanometer can measure, right? But the galvanometer current will be say Ig, and the current through the shunt will be given by 5 milliampere minus Ig. Okay, I am taking Ig also in milliamperes so that you can take this division. Now you have to find the value of Ig from this. Okay, so how to do that? Ig into G equals to S into 5 minus Ig. So students, what they make mistake is that they assume this 5 milliampere as the galvanometer current and then they start solving the question. Okay, that is not correct. You have to find Ig first. So 90 Ig, because G is given as 90, equals to 10 into 5 minus Ig, or 90 Ig equals to 50 minus 10 Ig, or 100 Ig equals to 50. Okay, this comes to the left hand side, becomes plus, so 90 plus 10 is 100, 0 gets cancelled, and you get Ig equals to 5 by 10 milliampere. Milliampere means 10 to the power of minus 3. So lastly we are putting the value of the current over here. So we get the current as 5 into 10 to the power of minus 4 ampere. So this is the current. Okay, current we have calculated. Divisions is given 50. Now as I mentioned, we will take 50 as the division, not 100. So what is the sensitivity? Sensitivity is given by number of division divided by the current. Okay, galvanometer current. So division divided by galvanometer current. Division is 50 and the current is given by 5 into 10 to the power of minus 4. So it will be 10. So 10 into 10 to the power of plus 4. Okay, this minus 4 goes up, so it becomes 1 into 10 to the power of 5. Okay, that's what answer is given. So you will take that as our answer. So 10 into 10 to the power of 4 is 10 to the power of 5, and they have mentioned 1 into 10 to the power of 5. 1 does not matter. So correct answer is 1 into 10 to the power of 5 division per ampere, and the sensitivity's unit is division per ampere, not ampere per division. Okay, it is division per ampere. Okay, now let's move on to the next question. I hope some of you have tried to answer it. Please send practice paper PU to PCMB given by board. Mood Baby is saying, Mood Baby, we will be solving that model question paper, don't worry. Okay, I cannot send it, it is already there. Okay, if you want the solution, definitely we are going to do that. Now Nagaraja is saying option 12C. No, not 12C. It is division per ampere. Unit is division per ampere. Okay, not ampere per division. Okay, it is division per ampere. If you calculate ampere per division, then it will be 10 to the power of minus 5. But here it is given as plus 5. So understand that. Okay, in some books they give ampere per division as the sensitivity, I know. But if ampere per division is given as sensitivity, then the value will be 10 to the power of minus 5, not plus 5. Okay, in this case we are calculating the sensitivity as division per ampere unit. So division per ampere unit, it will be 1 into 10 to the power of 5 division per ampere. Okay, Nagaraja, I hope your doubt is cleared. Yes, now he corrected it. Okay. Now let's move on to the next question. Now my board freezes, let me give some time. Okay, so now let's see the next question. So as you can see, whenever you see the questions, as soon as you see the options, you think that you started to think the question must be difficult because the options are given not in the uniform values. So that is the psychology of students, don't worry. A metallic rod of mass per unit length 0.5 kilogram per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degrees with the horizontal. A magnetic field strength of 0.25 Tesla is acting on it in the vertical direction. When the current I is flowing through it, the rod is not allowed to slide down. The quantity of current required to keep the rod stationary is. This is slightly tricky and long question. Okay, but not that difficult. Only thing that you have to remember some information from your PU 1 concept. Okay. Okay, some concept from your PU1, which is basically the gravitation. So whenever an object is located in an inclined plane, okay, there is a component of its weight acting downwards, which is given by mg. There is a component of weight acting along the incline, which is given by mg sin theta. There is a downward force mg cos theta. And there is a normal reaction. Okay, Now in this case, mg cos theta and normal reaction is not playing any role by keeping the object in place. So only thing that is taking it down is actually this mg sin theta. Okay, that downward force is balanced by normal reaction in this particular case, so it is not playing any role to move the object. Only thing that is trying to move the object is this mg sin theta. Now wire is not kept like this, the wire is kept like this. Inclined plane is a three-dimensional object, so inclined plane is out of the page like this, and the wire is kept like this, not like this, so don't confuse with this. Okay, so it is kept like this. Now it is trying to slide it down, but we are trying to send some current into it so that it can stay in balance. There is a magnetic field in the vertical direction. Okay, this angle is given 30 degrees. There is a magnetic field in the vertical direction, which is in this direction, B. Okay, current is going into the wire, right? A magnetic field strength of 0.25 acting in the vertical direction. When the current I is flowing through it, the rod is not allowed to fall. So that means there has to be some force in the opposite direction which will try to balance it. Now how to calculate that? For that we have to calculate the force that is acting on this current carrying wire. So what is the expression for force acting on a current carrying wire? This is given by BIL. Okay, now current and magnetic field, they are perpendicular to each other, so that means sin theta that we use here is not 30 degree but it is 90 degrees. Okay, so BIL sin theta, B sin theta is 90 degree, that is 1, so only F is equal to BIL is sufficient. Now what is then, so what is, how can we find the current over here? So there is a force, the direction of this force is L cross B. Okay, L cross B means L cross B, so it will be L in the direction of the current and then B, so it will be in this direction. Okay, so L cross B. Okay, so you have to know the rules of cross products. Suppose this is your finger, your hand, you have to first align your fingers in the direction of the first vector, in this case L, and then L cross B, right? So L cross B means L cross B. Okay, so if you forget, the vector form of force is given by I into L cross B. Okay, so first you point your fingers in the direction of L, then cross it, curl it towards the second vector, that will give you the direction of resultant vector. So this is the direction of force, but this force is not balancing it. Then what? So this force will have a component in this direction. Okay, so if this angle is theta, then this angle will also be theta, similar angle. So if this angle is theta, then this angle will also be theta. That means this is 30 degrees, so this will be also 30 degree, and this component will be F cos theta. Okay, because it's an adjacent angle, that means it will be F cos theta. So mg sin theta must be equals to F cos theta. So we will use that relation over here. So mg sin theta must be equals to F cos theta. Okay, this is the basic essence of this problem. So if you can figure this out, then your problem can be solved. Now m into g, we are assuming 10, sin theta is sin 30, sin 30 is half into is F is given by BIL. Now see, if you see the question, length or mass directly not given, mass per unit length is given, so that's why we have to take the length on the other side. So B is given by 0.25 Tesla, I we are trying to find, and length is given mass per unit length. So mass per unit length, we will take this length on this side and we will put the value. Okay, and cos theta is cos 30 root 3 by 2. Okay, so this is the basic problem that you have to solve. Now this equation you have to solve and calculate the answer. Okay, so what is the value of current? So current is given by M by L. So this L goes to over here. Okay, these two cancels, these two cancels, and we get M by L into 10 divided by 0.25 divided by 0.25. Okay, so what is the M by L? M by L is given as 0.5 kg Also there is a division of root 3. Okay, m by L is given 0.5, so we will put that. So 0.5 into 10 divided by 0.25 into root 3. Okay, so 0.5 into 10 is 5 divided by 0.25 into root 3. Now 5 by 0.25 is what? 5 by 0.25 is 500 by 25, which will be 20 by root 3. 20 by root 3 means what? 20 divided by 1.7 approximately. Okay, 1.7 approximately. Now this number is very close to 2, but still it is less than 2. Okay, so if 20 by 2 was there, 20 by 2 means it will be 10, but this 1.7 number is close to that number 2, but it is not exactly equals to 2. So our result will be slightly more than 10. Okay, slightly more than 10, approximately 11. Okay, so the current should be approximately 11 ampere, slightly more than 11 ampere. So if you see all the options, only one option fits the description, that is option C. Okay, so this is how you can approximate your answers. Okay, this is a way to approximate your answers. If you solve everything, after solving this, you need to check whether it is actually matching. Okay, if it is 1.5 or 1.4, then could have been 14, okay, or 15. But because it is very close to 2 but not exactly 2, the answer should be slightly more than 10. Okay, that is 11 we have taken, and our answer is clearly 11.32 ampere. Now let's move on to the next question. Please send practice paper PU to PCMB, send practice paper PCU PCMB given by board exam. Mood baby, as I mentioned, we will be sending that, don't worry. Okay, whenever we get the time, we will solve that and we will send that. Okay, already mathematics mathematics paper 1 is already released. Okay, and you are only asking about second paper. Oh no, send the practice paper. Send means I think you want you want the solution, right? Mood baby saying please send now. We will do it. We will do it maybe next week. I will be trying to solve the model paper in our live. So please go please have keep a track of it. Maybe next week we will be doing, we are not sure, we are planning something for your PU2 students. So please stay connected with us, join our WhatsApp channel, subscribe to the channel. Something big is coming for all the PU2 students, and that will be very, very game changing for you, and we are working very, very hard. We thought that you might be struggling with PU2 preparation, so that's why we are in discussion with something new that will going to change your PU2 preparation, how you prepare your PU2. Okay, so don't worry about it. Okay, we are here, we will try to help you as much as possible. Trust in us, have some faith in us. Okay, then definitely you will do well in your PU2. Don't worry. Now let's see, I think you are asking this right now because maybe your FA2 exam, the teacher said we will ask some questions based from your model question paper, but worry not, we will give you model question paper as soon as possible. A galvanometer of resistance 50 ohm is connected to a battery of 3 volt along with resistance 2950 ohm in series. A full scale deflection of 30 divisions is obtained in the galvanometer. In order to reduce this deflection to 20 divisions, the resistance in series should be. So here what we have is a galvanometer, resistance 50 ohm, and we have a series resistance of 2950. Okay, and a voltage that is connected over here is 3 volt, and it gives a full scale deflection of 30 divisions. Okay, so what is the current in this case? Current in this case is given by Ig equals to the voltage that you have applied divided by G plus R. Okay, so the voltage that you have applied divided by G plus R. So voltage that you have applied is 3 volt. Resistance of the galvanometer is given by 50, and resistance that you have connected externally is 2950. So it will be 3 divided by 3000. So it will be 1 upon 1000. So it will be 10 to the power of minus 3 ampere. Okay, so the Ig is given by 10 to the power of minus 3 ampere. So 10 to the power of minus 3 ampere gives you a deflection of 30 divisions. So 30 divisions reflects to 10 to the power of minus 3 ampere current. Now we want to reduce everything will be same. Okay, so this is the deflection. We want to only change this resistance, everything else will remain same, but this deflection should change to 20. That means we have to adjust this resistance such that the division reduces, that means the current changes. So for 30 divisions we get 10 to the power of minus 3 ampere current. For one division we get 10 to the power of minus 3 divided by 30 ampere current, and for 20 divisions how much current we require? We require 10 to the power of minus 3 divided by 30 into 20 ampere. Okay, so 0 0 cancels and we get 2 by 3 into 10 to the power of minus 3 ampere current. So this much current we require, okay, to change. By changing the galvanometer resistance we require this much amount of current. So you will use the same equation, only instead of R we will use a unknown resistance. So that's what our problem. Same equation we are using twice. First time we calculate the current, next time we recalculated the current for 20 division deflection, and then we will use the same equation again. So Ig is 2/3 into 10 to the power of minus 3, okay, and that is equals to the V by G upon R. V is again 3 volt, G value is 50, and R value we are trying to calculate. I am saying this is R dash. Okay, now do the cross multiplication. We get 50 plus R dash equals to 3 into 3, that is 9 by 2, 10 to the power of minus 3 in the division, that becomes 10 to the power of plus 3 when it goes up. Okay, so it will become 10 to the power of plus 3. So it will give you 4.5 into 10 to the power of 3, that is 4500. So 4500 is the 50 plus R dash. Now we have to calculate R dash. So R dash is 4500 minus 50, that is 4450 ohm. So 4450 ohm is the required resistance for this case. Okay, not model paper, I want practice paper PU2 PCMB, send please. Practice paper is available on your website, you can download and check it out. Practice paper is almost same. There are only 2 practice paper, by the way. Okay, not model paper, practice papers are only 2, that is for 2025 exam. Okay, they have given practice paper before exam, 2025 exam, for your paper 2 and paper 3. Okay, so that was published. For paper 2 and paper 3 they have published the practice papers. Practice papers are only 2, not 3. Okay, you are not receiving. Okay, you want to download it, it is there in their website. So if possible, tomorrow, today after live it is not possible. Tomorrow I will try to paste the link in the description of this video. Please check this video, or I will try to share in our WhatsApp channel. So please check the WhatsApp channel. I will try to share the link for the practice paper, either WhatsApp channel or in the chat section of this video, main chat section. Once the live is over, the main chat opens, you can comment there. I will try to post the link over there. Okay, I hope that solves your problem. Okay, hi Nataraju, okay, Nataraju, I think okay, Nataraju, I thought you are the same person as tomorrow we have maths preparatory. Maths preparatory right now it is only in month of November. Maths preparatory happens in maybe first preparatory. Second preparatory will happen in month of January only. Okay. Hello Sainath, you are late in today's class. Okay, class is almost 1 hour 10 minutes we are almost 1 hour 10 minutes into the lecture. Okay, only 5-6 questions left for the day, but welcome. Yes, mood I will send as soon as possible. Okay, mood, don't worry. Nataraj is saying 14C was correct. Yes, now he is saying 15A. Okay, let's see the question. A circular coil of wire of radius small r has small n turns and carries current I. The magnetic induction B at a point on the axis of the coil at a distance √3r from its center is. Okay, so circular coil has a wire of radius small r, has n turns and carries a current I. The magnetic induction B at the point on the axis of the coil at a distance √3r from the center. So what is the formula for magnetic field at a distance x is given by mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. Okay, so now we have to put the value of now here instead of capital R, small r as given as radius, and also n number of turns is given, so you have to put n over here as well. So now let's try to solve it. Mu naught by 2 into ni small r square, because here in this question capital R is given as small r. Okay, now small r square plus √3 small r whole square to the power 3 by 2. Okay, √3r is given over here. So now let's try to simplify. Mu naught by 2 ni r square divided by r square plus 3r square to the power of 3 by 2. Okay, so √3 square is 3. Okay, r square is r square, so 3r square plus 3r square is 4r square. So mu naught by 2 ni r square divided by 4r square to the power of 3 by 2. So 4r square means what? 4r square means 2r whole square, and if you take 3 to the power 3 by 2, that means this cancels and we get 2r whole cube. 2r whole cube means what? 8r cube. So the denominator is 8r cube. We will use that over here. So bx is given by mu naught by 2 ni r square divided by 8r cube. So square and this cube cancels and we get mu naught ni divided by 2 8s are 16 r. Okay, so mu naught ni divided by 16 r. So option A is correct. I think Nataraj answered option A. Yes, correct. Sainath also answered option A. I will try mood baby. As I mentioned, today after this lecture I have to travel back to home, then only I will be able to send, because the currently office is closed. Only I am taking the live from here. Okay, so I will try to send you the link, but tomorrow definitely you will get it. Okay, now let's move on to the next question. This is a slightly longer question. A proton moves with the velocity of 5 into 10 to the power of 6 j cap meter per second through the uniform electric field E vector equals to 4 into 10 to the power of 6 2 I cap plus 0.2 j cap plus 0.1 k cap volt per meter, and the uniform magnetic field B equals to 0.2 I cap plus 0.2 j cap plus k cap. Then the approximate net force acting on the proton is. So for that, what formula we will be using? We will be using the formula of Lorentz force, which is given by Q into E plus V cross B. So everything is given in coordinate form. So if you are trying to solve it, first you have to solve V cross B. Okay, and the cross product that we are going to use today is your favorite determinant method to calculate the cross product. So V cross B we are trying to find first. Okay, so I cap, J cap, K cap. Okay, I hope you are familiar with the cross product in case of two vectors, right? Now what is the first we will be using V vector. So what is the V vector? V is given as 5 into 10 to the power of 6 J cap only. So 5 into 10 to the power of 6 and remaining are 0, right? Nothing is there means remaining are 0. Now I can take this as common and I can write 5 into 10 to the power of 6 outside, right, because it's common from this row, remaining are 0. Now what about the next vector, B vector? B vector is given 0.2, 0.2 is common, so again I will write it outside the determinant. I cap means 1, J cap is 0.2 and K cap is again 1. So we have to simplify this determinant first. Okay, this one is we will take care of later. So first we have to take care of this determinant. So how to solve a determinant? First you cross this and this. So I cap into cross this and this. You get 1 into 1 minus 0.2 into 0. Now next it depends how you solve your determinant. Some students take this like this and they do the same cross multiplication and they use negative sign. Okay, I like to use the positive sign and I like to continue from where I have started. So I was ended at 0. So 0 into 1 is 0 minus then again we switch, 1 into 0 is 0. So even if you use plus method or minus method, does not matter, it will be 0. Okay, last is K cap. So what is K cap? Again we close the K and we do the cross. So 0 into 0.2 0 and 1 into 1 is 1. So minus 1. Okay, now simplify this. So we get I cap minus K cap. Very simple. And what about outside? 0.2 into 5 is 1. 0.2 into 5 is 1. 1 into 10 to the power of 6, obviously 10 to the power of 6. So this is our value of V cross B. This is our value of V cross B. Okay. Now we have to add this value with our electric field vector. So what is the electric field vector? Electric field vector is 4 into 10 to the power of 6 I cap 0.2 J cap plus 0.1 K cap. So we will do this now. So E vector plus V cross B vector. Okay. Now as you can see, 10 to the power of 6 is here, 10 to the power of 6 is here as well. So 10 to the power of 6 will be common. Now, so if you take 10 to the power of 6 as common, so 4 has to go inside and multiply with each and every term. So 4 into 2 is 8. So 8 I cap, and here also we have 1 I cap. So 8 plus 1 I cap plus 4 into 0.2 is 8 J cap. There is no J cap over here. So 0.8 J cap and plus 4 into 0.1 is 0.4 and minus 1 K cap, there is minus 1 K cap. So from here we get this as 10 to the power of 6 into 9 I cap plus 0.8 J cap minus 0.6 K cap. So this is the value of the this quantity. Now you have to multiply this with the charge. Charge is given here as proton. So proton means it will be 1.6 into 10 to the power of minus 19. Okay, so if you multiply this with the charge, you get the force. Okay, now it becomes little tricky over here. So 1.6 into this entire thing into 10 to the power of minus 13. So now you have to calculate the magnitude of this. Now how to calculate the magnitude? As you can see, the values are not simple, so it will take a long time if you want to calculate it. But there is a shortcut. So what is the shortcut? If you see that this 0.8 and 0.6 both are very, very small compared to the number 9. Okay, so approximately when you take the magnitude of this value, how to calculate, by the way, magnitude? If the value is a I cap plus b j cap plus c k cap, the magnitude is given by, suppose this is the vector r, then the magnitude of r is given by square root of a square plus b square plus c square. Okay, this is how you calculate the magnitude. So if you want to do this for this number, it will be very, very complicated and long. So we will only take the value 9. Okay, we will ignore the smaller terms. That is because in the question they said approximate value. Okay, so for approximation, j cap and k cap are small and we are ignoring them, and we are just using 10 to the power of minus 13. So what is this value? 9 into 5.4, that is 14.4. So 14.4 into 10 to the power of minus 13. So this is the value of the force. Little long question. So if you see the answer, so if you see the answer, the closest answer is this one. Closest answer for 14.4 is 15. So if you have included all these values, then you would have got 15 as your answer. Nataraj is saying, sir, will same questions will repeat in KCET? Same questions generally do not repeat in KCET. Okay, I will talk between the answers. Okay, so if you are asking a question, please be patient. I will obviously answer all of your question, but when I am solving the question, please give me the time to solve a question. Once it is solved, I will definitely answer all of your queries. Okay, now so what is the question repeat? It not all questions repeat, but in the history of KCET, yes, similar questions has come from time to time. Okay, so as you can see, one vector related questions has came in the past. Okay, and again the same vector related questions has come in here as well. Okay, so not exact this question may not come. Okay, but similar question there is a chance that it might come. Now from not from all the chapters, but from some chapters it has came. So who knows what this year they will ask the similar question like this in this year's KCET. So if you prepare the PYQs, there is a high chance that similar questions you might get. Also concepts are definitely getting repeated. So if you see the Lorentz force related concepts, definitely you will see more than one question that is coming from Lorentz force. Even the circular motion of charges in a magnetic field, which is based on Lorentz force, again that type of concept came in again and again. Okay, exact question will not come obviously, but similar question will come. The question which is based from this concept will come. Okay, that is what is important. And also it gives you an idea the difficulty level of KCET exam, difficulty level of a particular chapter. That's why you have to solve PYQs. Okay, understood? Sainath answered C. Yes, C was the answer, but you answered after I solved it. I hope you did it independently. Now question number 17. A solenoid of length 50 centimeter having 100 turns carries a current of 2.5. So if you see this solenoid based question, it came in the past in 2025 as well. Okay, same formula we used for solenoid. Okay, where I used it, here. So if you see this solenoid based question, mu naught Ni, the same formula, question value is different, the language is different, but the same question came again, which is actually asked some years back. Okay, so 2021. So this conceptual question came in 2021 and again in 2025. So if you see that, you will see a pattern here. Okay, so the similar questions repeat after some time, maybe not exactly the previous year question, but yes, if you solve at least 5 to 6 year questions, there is a chance similar conceptual questions will come. So you will have an idea what type of question, what level of difficulty is there in KCET. Okay, overall the difficulty level is easier because you have to answer 60 questions in 60 minutes, and main focus of KCET is how many questions you can answer correctly within that given time. That is very, very important. Okay, no one is expecting you to answer all the 60 questions. Toppers will definitely do it, they are practicing very hard, but if you want to fit into the top 1000 rank, then the main goal is how well you are prepared for your PU exam, and how well you can solve 60 questions in 60 minutes, how many of them you are able to solve them correctly, right? Okay. It varies, Nataraj. I have done a video. There will be one more video coming very soon, done by Jasmine ma'am. She was asking my help. She will post a strategy video. There you will get how many questions are coming from each chapter, what are all the high weighted chapter. The number varies slightly from year to year. I have done some videos in the past as well. For example, this chapter, magnetism and moving charges and magnetism, average question from all the years is 4. Okay, in 2025, 5 questions came, but average number of questions throughout the last 6-7 years is 4. So you can expect at least 4 questions that is coming from this chapter, and maybe 5th question might come from this chapter as well. There are some change in syllabus. If you have noticed that some concepts from some of the chapters are deleted, so total number of questions varies from the those chapters. For example, semiconductors, logic gate portion is completely deleted. Logic gates, Zener diode, those concepts are deleted now, so no questions will come from those concepts. Previously, logic gates and Zener diode based questions used to be coming in your KCET exam, at least one logic gate question, at least one Zener diode based questions. So those 2 questions are no longer coming, so those topics are now deleted. So that's why they have to accommodate that. So for example, your experiment based questions are now added to your syllabus. So 3 experiment based questions came in 2025, and according to my experience, 3 experiment based questions will again come in your 2026 exam. Experiment based means the experimental data collection that you do in your laboratory, the theory and the concept that you apply to perform a particular experiment, that directly they have given a table, experimental data table, and they asked you some question based on that. Okay, so those type of questions will come, 3 of them will come based on different experiments from your PU1 as well as your PU2. Okay, so that is very, very essential to remember. Now let's see this question. A solenoid of length 50 centimeter having 100 turns. So total number of turns is 100. Okay, the length is 50 centimeter. So 50 into 10 to the power of minus 2. This is the number of turns per unit length. So for solenoid based question, total number of turns per unit length is the most important thing. So you cancel it, 2. Okay, so you get 2 into 10 to the power of 2, that is 200. So total number of turns, even though 100 number of turns is given, number of turns per unit length is 200. So you will use that formula, B equals to mu naught Ni. Okay, mu naught is 4 pi into 10 to the power of minus 7, N is 200, and current is given in this case is 2.5. So if you see the difference between 2025 question and 2021 question, they have given the current which can be cancelled by 22/7. Here it cannot be, so you have to take the value as 3.14. That's it. Okay, 200 into 2.5 is 500. And if you take these 2 zeros out, you get 5 into 10 to the power of minus 5. 5 into 4 is 20. 20 into 3.4 is 6.18, and 1 0 was extra, so I will reduce it. So we get 6.18 into 10 to the power of minus 4, 6.28 into 10 to the power of minus 4. So correct answer is option D. Okay, so as you can see, the similar formula based question came again and again. Okay, that is the importance of, sir, which is the best book to practice questions? The best book, Sainath answered B17. No, not B, it will be D. Okay, you missed, maybe you have missed this 200. Okay, so I understood what happened. You, instead of using 200, you have used 100. So the trick is, length is not 1 meter, length is 50 centimeter. So you have to calculate the length per meter. Okay, so per meter means you have to calculate number of turns per unit length. Okay, so that is the trick. So be careful, be careful. Okay, there will be some hidden traps. So if you miss out on reading the question properly, you will miss out on the answer as well. So don't be in a rush. Okay, rushing is okay. There will be easy questions, you can just tick them off, but there will be some questions, just take at least 5-10 seconds, understand the information, understand the hidden trap and avoid it. Okay, Sainath? Yes. Which is the best book to practice question? Practice question practicing. If you just want to practice questions, there is obviously MTG book is there. Okay, we are planning to launch one PYQ book along with the chapter summary. We launched it, but there was some things missing in that book. We have withdrawn it, but we will launch it. You can buy that book as well, or you can wait for our Abhyas KCET test series. Abhyas KCET test series is a time limit exam test series where you will get the questions in the specific amount of time. You have to answer them. That is the best way to practice. If you just want to do the mock test or mock drill for your KCET, Abhyas KCET test series is one of the best. Last year we produced results. This year also we are planning to produce result, and the questions are obviously handpicked and chosen particularly for KCET level. And if you want to have a lot of heavy work, then MTG is one of the book which you can practice, but MTG is very, very large. If you have not started from the beginning, maybe it is not suitable right now for you. Okay, right now for solve questions from PYQs, that is very, very essential. Okay, some PYQ books give you some mock test paper as well. You should try them as well. And also as I mentioned, Abhyas test series will be launched in December, so you can buy that as well. Okay, that will be the main preparatory tools for your KCET journey. Now let's see question number 18. Easy question. A strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, moves in an opposite direction of the field, remains stationary, starts spinning. So let's see, this is an easy question. Smruti is saying, sir, 20 years PYQ solve Marute is to mark Barbodu. So if you solve 20 years PYQs, as I mentioned, Smruti, questions will not be exactly coming from PYQs. Similar conceptual questions will come. So if you are solving those questions on your own without looking into the solutions, or without looking into the solution for the first time, maybe you are looking into the solution, but second time when you are solving it, you are not taking any help and you are solving them within the given time limit, then definitely it will help you to score 40-45 marks. Okay, 40-45 marks can be scored by solving PYQs, not more than that. For that you have to explore beyond the PYQs, because PYQs are important, but that is not exactly sufficient to score 50+ marks. Okay, 40-45 marks can be scored if you practice PYQs seriously. Okay, if you just solve it one question and then you immediately see the answer, that will not going to help. Okay, you solve the questions in time, later on you check the answers. Okay, so that's how you improve. Now answer this question, everyone. Strong magnetic field applied on a stationary object. Okay, what will happen to the electron? Moves in the direction of field, moves in the opposite direction of the field, remains stationary, starts spinning. Sainath is saying option C, remains stationary. Yes, that is correct, because we know that in case of Lorentz force, magnetic component is given by Q into V cross B. So in this case V is 0. So if V is 0, then the force acting on the electron is 0. If the force acting on this electron is 0, then it will remain stationary. For example, if I don't ask you, please go and study, please study, please study, you will remain stationary, right? Because I am not affecting you. But if you feel that, okay, I have to move on my own, when you start moving, then my torque, my influence, whatever I am trying to do will help you. But if you are stationary, if you are only stationary, then no matter how much talk I do with you, how much inspiration I try to give it to you, you will remain stationary. So you have to take up the small step first, and once you take up the small steps, then only you will start accelerating, you will start moving, okay, which is very, very essential. So I am the magnetic field and you are providing the velocity. Okay, so I am there always, but you also have to take small baby steps towards the towards your achieving your goal. And if you are not doing it, you are missing out on a big time. Okay, everyone is running very, very hard. You also have to take the steps towards this goal. Okay, that is achieving less than 1000 rank. Two parallel wires in free space are 10 centimeter apart and each carries a current of 10 ampere in the same direction. The force exerted by one wire on the other. So Nataraj, I don't know whether you are here or not. The same question repeated in 2025. Not exactly the same, but conceptually the same. In 2025 the question was, one is taking current in this side, another one is taking current in this side. But in 2021 what they asked, they are carrying the current in the same direction. Okay, as I mentioned, similar conceptual question has come in KCET from time to time. Okay, the formula for this is given by the force per unit length. Force per unit length is given by mu naught by 2 pi I1 I2 by d. Okay, so what is the distance is 10 centimeter, each carrying current 10 ampere. So mu naught value is 4 pi into 10 to the power of minus 7 divided by 2 pi. I1 is 10, I2 is also 10, distance is given by 10 centimeter. Okay, so 10 centimeter means what? 10 into 10 to the power of minus 2. Don't get confused. Whenever you see centimeter, you have to use minus 2. Okay, so 10 cancels and we get this cancels, we get 2 over here. So this we get 2 into 10 to the power of minus 7 into 10 to the power of plus 2. This was in division, goes up, becomes plus. So 10 to the power of 10, that is 1, 2, 3, and minus 7, that is 2 into 10 to the power of minus 4. So 2 into 10 to the power of minus 4, and because they are carrying current in the same direction, it must be attractive. So 2 into 10 to the power of minus 4 Newton per meter, attractive. Same current, same directional current means attractive, opposite directional current means repulsive. Now let's move on to question number 20. A tightly wounded long solenoid has n number of turns per unit length, a radius small r, and carries a current I. A particle having charge small q and mass small m is projected from a point on the axis in a direction perpendicular to the axis. The maximum speed of the particle for which the particle does not strike the solenoid. So this is a question where we need to answer it using two different concepts. Okay, so first of all, there is a solenoid. Okay, now I am not drawing the solenoid like this. Generally solenoid is drawn like this, right? But I will take the cross section of this and I will only draw the cross section. Okay, I will only draw the cross section of solenoid, which is a circle. Okay, so this is the cross section of the solenoid. Central portion of the solenoid, this is the axis through which it is passing. Now you take a charge q and mass m and project it from the center. Now magnetic field is either into the page or out of the page. Okay, I am taking it into the page. Okay, solenoid magnetic field is like this, right? So when you take the cross section, it will either be into the page or out of the page. For now I am assuming it is into the page. Now you take a charge and you project it along from the axis, okay, in a direction perpendicular to the axis. Okay, so this is the axis, direction perpendicular to the axis. Now what will happen? So the force velocity is in this direction, the magnetic field is into the page. That means it will start spinning. The electron will start spinning like this. Okay, and if it does not strike the other edge of the solenoid, then the radius of this rotation should be half of the radius of the solenoid. Okay, the radius should be half of the radius of the solenoid. That is the main logic. If you understand this, then rest of the problem you can answer it. Okay, so what is the formula for radius of a circular motion of a charge in a magnetic field? It is given by mv by qb. mv by qb. Okay, but in this case the radius is r by 2. What is magnetic field B over here? B is mu naught Ni. Okay, number of turns per unit length is given. So just put these values and you have to calculate the velocity. Okay, the maximum velocity that we are trying to calculate. So now put the values mv by q into mu naught Ni. So we are trying to find the velocity v. So do the cross multiplication, we get mu naught q Ni into r divided by 2m, and that is our velocity. Okay, so let's see the option. Mu naught Ni qr divided by 2m. So definitely correct answer is option B. Okay, Sainath is saying option A. No, Sainath. Again, the trick is when you release the particle from the axis itself, it rotates only half. Okay, it only rotates half circle. So that means it has only have radius r by 2, not the entire radius. If you release it, suppose if you release it somewhere here, then it will have the entire path to travel. But because it is only traveling at the center, it will only have the halfway to rotate. Okay, if it is on the edge, perhaps in that case it will take the entire solenoid, but for this particular case it will only be rotating through only half of the solenoid. That means the radius is not r but r by 2. So this is the trick. This is the only trick in this question. Remaining, just you put the formulas and you can calculate it. Okay, Smruti saying option A. Sainath again corrected. Yes, Smruti, Sainath. Sir, do you provide crash course in March? Yes, Sainath, we will be providing crash course in March. They will be offline, online, everything will be there. You can join in. If you are part of KC90, then you will get it for free without any extra cost. Okay, so crash course will be there in the month of March. Okay. So this is the end of today's lecture, and as I mention every time when I am here, please don't forget to subscribe to our lecture, our channel, and join the WhatsApp channel if you have not yet done so. And I will be coming back with a live session very soon, with a new chapter. Till then, bye, and good night to everyone. Thank you for supporting this channel and also having trust on us. We will try to deliver you the best content as much as possible.